Hello students, and I welcome you in this PM class. Now we are going to solve the exam question which I have extracted from September December 2022. You can see that I have opened the real past paper, and it is the ACCA practice platform. September December 2022 is the past paper. The name of the question is ketone. You can also find it in your exam kits as well. So let's first read out the requirement, and then obviously I will be solving it on this spreadsheet, right? So first of all, for 13 marks, as you can see on the right side of your computer screen, construct a payoff table. Now do not embarrass me, you do not know what is the payoff table. All of you know what is payoff table. Payoff table actually means that it is the table which is showing all the possible outcomes of different options, right? It is showing all the possible outcomes of different situations, different circumstances, showing all the possible profit outcomes, and recommend the level of production should choose based on expected values. Now you might have heard that there is a risk seeker, risk averse, risk neutral, and that is maximax, maximin, and expected values. So I am pretty much sure that you people have covered all the basic topical lectures, and now let's start constructing a payoff table. So what I have taught you in the regular class, that whenever you are supposed to construct a payoff table, see that in payoff table, see that it is very much simple point. Whenever you are drawing the payoff table, you should identify first. What you should identify, number one, controllable factor, and number two, uncontrollable factor. You all know that what is controllable and uncontrollable. It is very simple thing which should be crystal clear to all of you, that every aspect on which you have to take the decision, every aspect on which you have to take the decision is called controllable, and what is uncontrollable, on which the probability will going to be applied. Now let's see that there are two aspects. One is controllable and another one is uncontrollable. Now, what is the identification criteria of controllable and uncontrollable factors? Controllable factors are those factors on which you have to take the decision. So in a shortcut way, I'm writing that is the decision making criteria, decision making aspect. And what is uncontrollable? It is that factor on which probability is applied. On which probability is applied. Now that is very much simple point to identify from the given case study, right? So let's first identify what is the controllable factor and what is uncontrollable factor from this given case study, and then we're gonna be solving this question, right? Let's move on. KeyTone is a recently established business specializing in the manufacture of a range of products for the fitness and health food market. It has recently developed a new product, Protein Power. Protein Power is basically the name of the product, which it is almost ready to launch. KeyTone estimate that demand will be between 3,000 and 4,000 units per month. They are estimating that demand can be either 3,000 and 4,000 or in between. But Protein Power can only manufacture in batches of 500. This is a very important and highlighting point, that you can only produce this product in a batches of 500. That means one batch is equal to 500 units, right? That means one batch is equal to 500 units. Therefore, KeyTone must decide. Please see that this is must decide. That is, you must have to decide whether to manufacture 3,000, 3,500 or 4,000 units. So what is the thing? That means your controllable factor, that means your controllable factor is, the production level. Either 3,000 either 3,500 or 4,000, right? This is the simple point. So this is my decision making criteria: 3,000, 3,500 or 4,000 units. This is my production level. Now let's move on. Given the short shelf life of protein powder, any units remaining unsold, any units remaining unsold, this is a very important point, at the end of each month must be thrown away. Please note that this is a very important highlighter point. Any units remaining unsold, wait, I should change the color so that it will be visible more clearly. Remaining units unsold. So what does it mean? What does it mean? It means that you are producing the units. You are, let's suppose you have produced 4,000 units, but it has not been sold. So they must, and they have no scrap value. See that they have no scrap value. They have no scrap value, plus, they have no scrap value, plus, it must be thrown away. It must be thrown away, right? It must be thrown away. So this is also the important point, that it must be thrown away. That means you have to dump it, thrown away, and it has no scrap value. That means the production is must. So we have got 3 decision making point, right? Congratulations. Now, how to construct the payoff table? Whatever your controllable aspect is, whatever your controllable aspect is, you need to write it here like that way. Here like that way. You know, payoff table look like that way, right? So what's the controllable factor? This is my 1, 2, 3. So this is my production level, either 3,000, 3,500 or 4,000. So whenever you have identified your controllable point, you must need to draw the payoff table like that way. So before going to start reading ahead, I'm just going forward for this particular thing, part A. I am giving the heading over here, part A. And here we can write like that way, production level, right? This is my production level. So this is my 3,000 units, 3,500 units, 4,000, right? Okay. So this is my production level in terms of number of units. Right? So I had written it down over here. Production level 3,000, 3,500 and 4,000 units. This is my, you know, controllable point. And then you have to draw a very small column of probabilities. And then what you are supposed to do, write that thing on which probability is being applied. That's a very much simple point. So here I am writing probabilities, right? I am writing probabilities, and the next one should be that particular aspect on which probability is being applied, and that is the uncontrollable aspect. That is the uncontrollable aspect, right? Now let's move on. The following variable cost, okay, I am not going, see that demand level probability is being applied 3,000, 3,500 and 4,000. So it is the demand level. It is demand, right? It is demand. It is demand. And what is the demand? The demand is also 3,000, 3,500 and 4,000, right? So this is my demand level. And what is the probability? Probability is given like 0.2, 0.3 and 0.5. So this is my demand level and my probability is also given. So please note that congratulations, you have almost half solved your answer, because the skeleton of payoff table is very much important. So first you have to draw the controllable aspect in the horizontal way, like I have drawn over here. Next we have to insert the percentage column and then write that thing over which the percentages are being applied, right? Now that's a very simple point. So if I can simplify my answer with you people, 1 2 3 4 5 6 7 8 9. So we have got 9 possible outcomes. That simple means we have got 9 different profit statements. So we have to, what we are supposed to do, we have to calculate 9 different profit outcomes. So every single cell is having a different scenario. So we have to carefully read the question and perform my answer accordingly. Right now, let's move on. So going above, the variable production cost, but remember one point, that this is a very golden line in this point. Any units which is produced but not sold. Repeat, any units produced but not sold. So what does it mean? It has been produced but it is not sold. So that means the condition is applied over here that production is necessary. You have to produce, and if it will not be sold, you have to throw it away. So that means the production cost is static over a particular production level, right? So now let's move on towards the further information. So this is a very simple, crystal clear. The variable production cost of making one unit of protein is as follows. This is direct material, labor, and variable overheads. This is per unit material, per unit manufacturing cost. Protein will be processed on machine X every time. This is a very important point. Every time the machine is set up for a new batch of 500 units. Why? Because in this particular question, one batch is equal to 500 units. So the machine is going to be set up. What is the setup? Setup means that getting the machine ready. Okay, the oiling is done, the machine is ready to produce. That's called the setup. Just like that way, imagine there is a restaurant who is producing pizza, burger, whatever the food they are serving. So there is a stove, there is a big stove. It needs to be switched on sufficient time before it's being processed. So that's called the the setup, the setup. So the setup requires the cost. So one batch is equal to 500 units. The machine is going to be set up. Every time the machine is set up, it must be cleaned and inspected at a total cost of 240. So this is, we can say that this is my 240 cost for one setup. And one setup means one batch of 500. Every time, what is written? It is written every time the machine is set up. Every time the machine is set up. In addition to the above production cost, KeyTone company incurs selling and distribution cost. Please note that this is the selling and distribution cost. This is not any other cost. Selling and distribution cost $0.9 for every units sold. Every units sold. So keep the things simple and natural. Here I am now going towards right side, and I'm just writing in cell number H3 production cost. Sorry, not the production cost. I'm simplifying my answer. This is my variable production cost. Variable production cost. So keep it very simple. My variable production cost is equal to 6.2, that is material, plus. So whenever I will be needing the total cost, I will just have to select my total variable cost. 6.2 plus 2.7 plus 1.35. So this is 10.25. This is variable production cost. Variable production cost 10.25 on per unit. It has been given. So I have not written anything abnormal. I have written simply the total. Every time the machine is set up for a new batch. Now please note that the production level can be either 3000, 3500 or 4000, right? So this is a very simple point. This would be my production level. This would be my production level. Now please note that in this production level, there will be setup. And one more thing, yes, go above, in a batches of 500, right? So I am writing over here just to simplify my answer, that is number of batches. Number of batches. So at how many production are there? 3000, 3500 and 4000. So at 3000 units, at 4000 units, at sorry, at 3500 units, at 4000 units, right? So number of batches. So number of batches, that means in one batch, there is 500 units. So how many batches are there? That means 500 batch, 500 batch, 500 batch. So how do you calculate this thing? 3000 divided by 500. That means 6 batches. That means 6 batches, right? 6 batches. Here 3500 divided by 500. That means 7 batches. Here 4000 divided by 500, that means 8 batches, right? That means 8 batches. So it is very much simple that I have got number of batches, and every time, see that every time the machine is set up for a new batch, there is a cost of 240. So I will be counting this 240 in the form of batches, not supported with the number of units, right? So it's very much simple. And this is selling for every unit sold. Note this point, every unit sold. So there is a trick and crack to read the question as well. I'm also reading the question with you, right? So let's now move on. KeyTone has launched only one other similar product, and is based on the information from that launch, has estimated that probabilities associated with each demand level for protein are as follows. Okay, I have accounted for this thing. However, while KeyTone company believes that it could achieve a selling price of 35 per unit to sell up to 3500 units, up to 3500 sorry sorry up to 3500 units, the selling price would be $35, right? So that means when you are selling up to 35, up to maximum, up to, so your selling price would be $35, right? What's next? It would need to charge a lower selling price of 33 per unit for all units sold to achieve a sale volume above this. That means when I am selling, 3000 and 3500 units, so the selling price would be $35. In order to sell 4000 units, selling price needs to be lower down, and it will be $33 per unit, because you have obviously the rule of demand and supply would have been applied over here, that in order to sell more and more units, I have to lower down my selling price, right? So that's a very simple point. 33 per unit for all the units sold above this volume. Okay, that's simple. No need to highlight this point. The managing director is very risk averse. Okay, I will be reading this information later on. So first of all, for part A, construct a payoff table to show all the possible profit outcomes and recommend the level of production KeyTone company should choose based on the expected values, right? So first we have to prepare the payoff table. Now let's move on. So this is my working number 1, 2, 3. Okay, now see that I will be counting my working number 1 like that way. So this will be my working number 1, working number 2 and working number 3, right? So this is like that way. I can simply write here W1, working 2 and working 3. But I need to show this profit figure into the next cells, columns, because I will be getting 13 marks of these calculations. So obviously I have to solve. So see that how gently we have calculated the number of batches, the production cost, and so and so. So here I am writing some income statement workings. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9. I've been centering it. Okay. Okay, so I'm now starting it from here, from this cell number L. This is my sales, my variable costs, right? Let's do one thing. First of all, let's start with working number one. Working number one, right? So that it will be easy for you to see which calculations I am doing it over here. This is my working number one, right? This is my working. What is exactly the thing? Production is 3000 and demand is 3000. So simple. I will be producing 3000 units. In working number 2, I will also be producing 3000 units. Working number 3, I will be producing 3000 units, right? Fair enough. So working number 1, 2 and 3, I will be producing 3000 units. So let's move on first. This is working 1, working 2 and working 3. So what is the variable cost? I will be producing 3000 units. So what is the production cost? Is equal to 3000 multiply by this is the production cost 10.25. So that means it can be copy and paste over here. Or sorry, it's not being copied over here. Okay, no problem. We are just writing it over here. 3000 multiply by 10.25. 3000 multiply by 10.25, right? So this is the very simple point. In this working number 1, 2, 3, I got this thing. But see what is happening in working number 1. This is my working number 1, right? Working number 1. This is my working number 1. What is exactly the point being covered over here? I am producing 3000 units and there is a demand of 3000 units. So naturally, my selling price would be 35 per unit, right? 35 per unit. Now see that 3000 multiplied by 35. So I got this sales and this is my variable cost, right? Sales and the variable cost. And the next one is about 240. This is 240 per batch. This is 240 per batch, right? This is 240 per batch. And how many batches are there? There are total 6 batches. So let's open the calculator. 6 batches in 3000 production. So see that 6 multiplied by 240. It's 1440. So 1440 is my, you can say the setup cost. But setup cost is being measured in the form of batches. So this is my setup cost. So in all these 3 workings, I am producing 3000 units. In all these 3 workings, I am producing production is 3000 units, right? So see that for our convenience purpose, I have written it over here. Right? Production is 3000 units. So what is the setup cost? Is equal to 240 multiplied by 6. You can just copy paste over here. So simple. Setup cost has been done. Now move next. There is one more cost which is the selling cost and that is $0.9. $0.9 for every unit sold. So how many units are being sold in the working number 1? There is selling cost. In selling cost in working number 1, I can sell 3000 units multiplied by 0.9. Multiply by 0.9. So what is the profit figure? What is the profit figure? Price is equal to sales minus variable costs minus setup cost and minus selling cost. So I got 70110. That's very simple point. So here I think you may be confused with the setup cost. So I can open this cell. That is, you can see that 6 batches multiplied by 240 is per batch cost, right? So that's a very simple point. So if you have successfully calculated one profit statement, now the similar pattern will be followed for all the next payoff table profit figures. Now in working number 1, what should I do? I just need to click is equal to, move right side, press on the profit figure, enter, it will be displayed over here, right? It will be displayed over here. So that is my, with this blue color profit figures, right? Now in working number 2, see that in working number 2 you are producing this 3000 units. You are producing 3000 units and the demand is 3500. Now see, this is a very simple point. I have produced 3000 units. 3000 units are here at my shop, but the demand is 3500 units. So how many units I can sell? I can sell only 3000 units because I have 3000 units at my shop and you are here for purchasing 3500 with obviously different number of customers. So I can maximum sell 3000. I cannot sell more. And the same pattern will be applied it over here with the 4000 units because I have produced 3000 and there is a demand of 4000, right? So let's now move on. So in all these three, I will be selling 3000 multiplied by 35. And you can copy paste this formula. Here selling cost is 3000 multiplied by 0.9. Oh, sorry. It's 0.9. So the same figure in all these three workings, there will be a same thing. So here 3000 multiplied by 35. So you got this thing 701100. So all these three have got the similar profit figure. No need to worry about it. Why? Because you have produced 3000 units and the demand level is getting exceeded. So definitely you can maximum sell 3000 units, not more than that, because you haven't produced more than 3000 units. So that's a very simple point. The calculations are in front of you. You people can copy this. Now let's move on. So here is equal to this value, okay, is equal to this third value. So see that the figures with blue color represents your profit figures. Okay. Now production level 3500 units. Now what does it mean? Please note that at all these three levels, with your yellow boxes, wait, actually I have to simplify my point as well. In all these three yellow boxes, there is a production level of 3500 and it will be fixed. How I came to know it will be fixed? Because it is clearly mentioned in the question, any units remaining, that means units produced but not sold must be thrown away and have no scrap value. That means it's simply your loss. So the basic principle here is that you have to produce 3500 units. That's it. So make your calculation journey bit easier. Here I am now going to solve working 4, working 5 and working 6, right? So I can simply write for you people over here with again this red color, that is production is 3500 units, right? Production is 3500 units, and so variable cost will be applied on 3500 because it is clearly mentioned in the question, any units remaining unsold, right? At the end of each month must be thrown away. That means units produced but not sold, units produced not sold, produced not sold. So that means production is necessary. So is equal to, come over here, is equal to 3500 multiply by 10.5. This was the value, right? 10.5. Press enter, answer is equal to 3500 multiply by 10.25, sorry, 10.25. And here 3500 multiply by 10.25, right? Now simple point is that, but now 35, there is yet another cost, that is setup cost. Please see that this is the setup cost as well. What is the setup cost? Setup cost is being based on the batch, on the basis of number of batches. So how many number of batches are there? 7 batches for 3500 units. 7 batches, 7 batches, 7 batches. And per batch cost is 240. See on the left side of the screen, right? So 3500 is equal to 7 batches multiplied by 240. And it will gonna be same over here, right? But the selling cost would be different because the selling cost is based on how many number of units you have sold. Now, working number 4. Please turn on to the next working number 4. Just see, students, just see this yellow colored cell. You have produced 3500 units, but you can sell 3000. That means I have produced 3500 units. I have to bear the cost of 3500 units, cost of production, but units will be sold 3000. The rest of 500 comes under the cost. Finish. No need to account it for. Simply, I have to bear that cost. So the demand is 3000. Here in this cell, second yellow cell, demand is 3500. Okay, just hold on. Here the demand is 3000 and your selling price is 35. Selling price is 35, right? I have to write it. Working number 5. Demand is 3500 and the selling price is 35. Fair enough? Good to go? Okay. And the next one is the demand is 4000. Now the third yellow cell, here the demand is 4000 and the company will have to charge $33 selling price because in order to make in order to sell more units, you have to charge lower selling price and that is $33. So 4000 is equal to 4000 multiplied by $33, right? Press enter, answer. Now selling cost. Please see that selling cost is based for every unit sold. Here I have sold 3000 units multiplied by 0.9. Here I have sold 3500 units multiplied by 0.9. Here I have to sell 4000 units multiplied by 0.9. That's a very simple point. Press enter, answer. So at the last, you have to calculate the profit figure. For the profit figure, you can simply copy paste any one cell over here. Because when you are copying paste, so the formula is being copied. But please follow this technique very gently. If you are not comfortable, so write the formula in every cell. So, I got this answer. But one more important point to be noted over here. We need to see that here I cannot sell 4000 units. Why? Because my production is 3500 units. So definitely I can maximum sell 3500 and it will be at 35. So I mistakenly took 4000 figure. Why? Because the demand is 4000. The demand is 4000, as you can see. Sorry, first of all, let me correct this. So every unit sold, and that is also 3500. So it will be the same figure. Now please see that in the last cell, the demand is 4000, but I have produced 3500 units. So obviously I cannot sell more than 3500 units. So what I'm not going to do, just click over here is equal to working 4. Just click over here, working 5. Just click over here is equal to working 6, right? So this is the thing. Now please note and correct this thing that in working number 6, regardless of there is the demand of 4,000 units, I cannot sell more than 3,500 units. So that's a very simple point. All right, students. So I am assuming that you people have made the correction in this and in this cell as well, because we have sold 3,500 units. Right now, for the next one, for the next one, the production is okay. I have to come over here. Now the production is 4,000 units. Right now, see that for working number this and this, in all these three selected cells, with yellow color, there is a production of 4,000. So that means units produced but not sold. You have to produce 4,000 units in all these three circumstances, right? And the cost of production is 10.25, right? 10.25. So first of all, without wasting any time, I'm writing here this thing, that is cost 4,000 multiplied by 10.25. So it would be same in all these areas. And then there will be setup cost. Setup cost. Please see that setup cost at 4,000 units are 8 batches. And setup cost is being based on number of batches. It is based on number of batches, right? So it is 8 batch multiplied by 240. So is equal to 8 multiplied by 240. It would be same. Now, the difference is the number of units. Please see that in the first yellow shaded cell, there is a demand of 3,000 units. I can sell. Number 2, there is a demand of 3,500 units. I can sell. Number 3, there is a demand of 4,000 units. I can even sell out it, right? So at these two levels of demand, my selling price is $35, and above that I have to sell at $33 per unit, right? So let's now move on. Sales is equal to 3,000 multiplied by 35. It's working number 7, working number 8, it's working number 9. Right? So at working number 8, I have to sell is equal to 3,500 units multiplied by 35, and here working number 9 is equal to 4,000 multiplied by 33, right? So that's a very simple point. Okay, now the next one is the selling cost. Please see and note that selling cost is based on number of units sold. So here I have sold 3,000 units multiplied by 0.9. Here I have sold 3,000 multiplied by 3,500 multiplied by 0.9. Here 4,000 multiplied by 0.9. That's it. And please note that at in order to sell 4,000 units, you have to reduce your selling price to $33. Now simply calculate the profit figure. Now this is my profit figure, right? So I have computed these three profit figures for working number 7, 8 and 9. Now what I have to do is simply follow the same way, is equal to working 7 is equal to working 8 is equal to working number 9. So see that how professionally we have prepared our payoff table, right? We have prepared the payoff table like that way. So this is a very simple point. And I have to show the workings of working 7, 8, 9, 8 and 9 so that you people can also verify with your own calculator. But the bottom line point is that in this kind of a question of payoff table, you must have to read and go through the case study. You must need to, think about the skeleton, how the payoff table would be looking alike, and then you have to prepare the payoff table following that technique I have taught. Good. Congratulations, we have prepared the payoff table. Now, still, we have not got complete 13 marks and recommend the level of production ketone should choose based on expected values. Now, let's move on towards the expected values. Simply, you need to refer to the payoff table. Expected values. What is expected value? Expected value means, if I can show you on my rough page, expected value means this is my EV, that is whatever the amount you have to multiply with P, that's called probabilities, right? That's called probabilities. So if I can go to the 3000, now let's say for example, I have to calculate expected values. I have to calculate what expected values, right? Please see expected values. How you can calculate the expected values? Press is equal to bracket open. This value multiply by 0.2. Bracket close plus this value, because expected value is of your decision making point. Expected value is not of your demand. Expected value is of your decision making point. That is the level of production. Multiply by 0.3 plus 70110 multiply by 0.5 bracket close. This is the expected value. And here expected value press is equal to bracket open. This value multiply by 0.2 plus this value multiply by 0.3 plus 81,000 multiply by 0.5 bracket close. Press enter, answer. Please remember, expected value is not of the uncontrollable factor. Expected value is of your decision making. Expected value is of your decision making. Press enter, answer. And here it is expected value. Press is equal to this value multiply by 0.2 plus 76,000 multiply by 0.3 plus 85,000 multiply by 0.5 bracket close, answer. So which of the expected value seems to be high? That is this one, 78,000. And so okay, and so based on the expected value, we should produce 3,500 units. We should produce how many units? 3,500 units. So what's the name of the question? That is KeyTone Company. KeyTone Company should produce 3,500 units based on expected value, since it has got highest PV. Okay, so at the end, I have written my answer. Apparently, the question sometimes seems to be, what shall I say, seems to be complicated because of the data, because of the presentation. But when you are reading the question with the thorough attention, you can easily identify and crack the question, identify the figures. Uh-oh. Okay, students. So for part A, now we got complete 13 marks. Congratulations. We got complete 13 marks. Now part B, calculate the maximum fee which Ketone company would be prepared to pay the market research company for the information about actual demand level. Now this is basically the value of perfect information. Now this is basically the value of perfect information. I shall be writing this. This is the value of perfect information. Now what is this value of perfect information? I should be writing that is the fee for the market research. This is fee for the market research, right? So if you can align the cell, no need to worry about it. The above values will be adjusted automatically, right? So fee for the market research. Now, what is this? This is actually the value of perfect information. Now, if I can guide you in a very simple way, that is, there is information. If you people remember from your basic topical lecture, the information would be either perfect, the information would be either imperfect, right? Either perfect or imperfect. So the perfect information is that which is 100% accurate and in which there is no doubt. So obviously, when I'm asking you to pay me the money for the market research, so naturally you are asking for the perfect information, right? You are asking for the perfect information. But what exactly the perfect information is? But what exactly the perfect information is and what is the value and how does it how it's being calculated, fine. So naturally, what is the perfect information? Now let's say, for example, there is a market research company. There are people who conduct market research. They meet people, they read articles, they search on the internet, they use their own mindset, they use their own probabilities as well because of their expertise. So all of these elements will be mixed together, and I am the person who is carrying out the research, and definitely I will charge payment from you because I have to meet Mr. A, Miss B, Mr. C, XYZ. I have to use my time. I have to use my commercial sense. I will be assigning the probabilities. I will be analyzing the news channel. I will be analyzing the political economical elements, and I will be in a search of the perfect information in which there should be no doubt. So definitely, if I'm doing many efforts for you people, definitely I will charge money from you, and that's called value of perfect information. Now what is this value of perfect information? It's very important point to be recalled. All the way you people have covered all these things from your basic topical lecture, but still along with this question I am explaining it once again. So what you are supposed to do, simple point is that value means benefit, sorry, value means additional benefit. Now, when something has got additional benefit, so there must be some existing benefit. Now, let's say, for example, you need to calculate EV if there is no information. Now, what does it mean? Shall I make this line very simple for you? Obviously, yes. EV if there is no information. Now, what does it mean? It means that calculate EV of every option. Now see that I have no information. I have no information at all. So definitely I will be selecting that decision making in which there is a highest EV. So it means EV of every option. and select the highest one. If I will be having no information, naturally I will be selecting the option having highest EV. So this is the very first step, and I think we have got this thing. So in the first step, EV, if there is no information, EV if there is no information, right? So in the first step, if there is EV, if there is no information, I do not need to calculate it. It is simply available over here, this value. So press this and link here. That's a very simple point. So this is my first step, right? First step. Second step. Now the second step is EV if there is perfect information. Now this seems to be the confusing statement. Again, following my way to simplify the things. What does it mean? EV if there is perfect information. Now second point is that, first listen to me very carefully. Okay, let's wait. EV if there is perfect information. Please point to be noted. Your decision making should be based on the market. Now, what does this statement means? It means that you have to calculate EV. You have to you have to identify that option having highest value but following uncontrollable element. See how? Let's get to this payoff table. Now see, this is my demand level. If my demand would be 3000 units, I will be selecting this option. If my demand will be 3500 units, I will be selecting this option. If my demand will be 4000 units, I will be selecting this 85 option. So if my demand is 3000, I will be going to this value. If my demand will be 3500, I will be going to this value. If my demand would be 4000, I will be going for this value. Right? I will be going for this value. So what does this indicate? It indicates that if I will be having perfect information, I will be definitely identifying that option in which there is a highest return, right? So please note all these points. This cell, no fills. This cell, no fills. And here it is also no fills. Now again, if my demand would be 3000, which option is considered to be the best one? Obviously 7000, 70,110. So that's called calculate, but you have to calculate EV, right? Calculate EV calculate EV following uncontrollable factors of all and make it 100% as well, right? Make it what? 100% as well. Now let's move on. Okay, so if my demand would be, now I am making this as an heading and writing in as a subheading. If demand is 3000, if demand is 3500, if demand is 4000, right? not 18, it should be 14. So all these should be 14. Okay, now see that if the demand is 3000, let me adjust the font size. Okay, if demand is 3000, see that if the demand is 3000, I think I should go with this value 70110. 70110 and its probability is 0.2, right? So is equal to 70110 multiply by 0.2. I have to multiply, got this answer. Next, if demand is 3500 units, so the better option is 81795 is equal to 81795 multiply by 0.3. Multiply by 0.3, right? Press enter, answer. And if demand is 4000 units, so definitely I should go with this value 8500, sorry 85,000. If demand is 4000, right? So press is equal to this multiply by 0.5. Got this answer. Now what you have to do now? Now understand the logic. If I am not having any information, I will be selecting this thing. I will be gaining the value. That means the benefit, the return. If I am having no information, I will be calculating the EV of every option and I will be going for this 78,385, right? And if I will be having the perfect information in every three scenarios, for example, if there is a market demand of 3000, so if there is a perfect information, I will go with this. If now this whole chapter is based on what if analysis. If demand is 3500 and if I will be having the perfect information, I will go with this highest return. And if I will be having 4000 demand and if I will be having the perfect information, I will be going with this value with the highest return, right? So all these three circumstances, there is a technique being applied. What if analysis. What if, select the best one. So if I have no information, I am happy with this. If I have perfect information, there are three scenarios and I need to club it up, sum it up. Oh, sorry. Make it total, this thing. Now, please analyze, please analyze. If I will be having no information, if I will be having no information, this would be the return for me. If I will be having perfect information, I will be having a return of this. So when I had no information, I got 78,000. When I get perfect information, I am getting 81,300.5. So you have to take the difference of two, that is step number 2 minus step number 1. So that's called the value of perfect information. Again, now third step would be value of perfect information. Now the third step would be value of perfect information and how to calculate it. See, again, I had no information. There is a benefit of 78,000. I will be having benefit if I will be having perfect information, that is 81,000. So what's the difference? The difference is the additional value of perfect information. So this figure minus this figure, right? 2195, or you can round it up to the 2196. So if for example I will be asking you that give me the money for the perfect information, you will be paying me this value, not this value. Why? Because this is the benefit you would already been earning. Because of my information, you are getting additional benefit of this. So practically you should pay me less than 2195. Practically you can you should pay me 2195, but how much you would be prepared to pay? How much you would be prepared to pay? That is this amount, not more than that. But practically speaking, you should pay me less than 2,915, right? So this $2915.5, or call it 21916, is the maximum fee which can be paid to acquire the perfect information from the market research company. So congratulations, you have completed this value of perfect information as well. So the point to be noted is that reading the question, analyzing and analyzing the scenario from it is utmost important. You people can pause this video and start copying this. So congratulations, we have completed this part as well. That is part B of 3 marks. We have covered 13 marks requirement, 3 marks requirement, and now we have to go to part C. Next, part C. Briefly discuss for 4 marks. 20 marks, the question would be completed. Briefly discuss whether it is appropriate, yes or no, whether it is appropriate for the managing director to use expected values on a basis of for making the decision about the production level of protein powder, and explain one alternative decision criteria which might more useful. So let's first of all, let me give you a very quick recap about the things. You know that there are 3 different risk attitudes. Attitude toward risk. Attitude means the mindset. So number 1, there is risk seeker. I'm not teaching you, I'm just giving you a quick recap of this thing. There is a risk seeker, right? There is a risk seeker, and its decision making criteria is, maxi max. What do you mean by this terminology, maxi max? If I am the risk seeker, I am an optimist personality. I will be looking forward for the best and the ultimate best outcomes. So that's called maxi max, maximizing the maximum return. Number 2, there is risk averse. Risk averse is actually the person Risk averse is actually the person who is afraid from risk, who gets afraid from risk. So he is looking for the least outcomes with the maximum benefit. Like that way, if I am taking the decision, I will be saying what would be the maximum least. This could be the loss. Okay, so I have to find the least outcomes, and then I will be going towards finding the best, right? And so called maxi min. And number 3rd one is the risk neutral. Who is risk neutral? He is neither risk seeker nor risk averse. So he will be taking the decision based on expected values. So that does not mean that whatever the criteria seems to be suited. No, it depends on the risk attitude, the mindset. If you are having a risk seeking mindset, you will drive very fast. If you are a risk averse, you can drive slow. If you're a risk neutral, you will see the probability in order to decide whether to fast or slow down your drive, right? So it depends. I just gave you the simple example. Now let's move on towards this particular thing. Okay, let me explain you one thing, that Maximax. Let's say Maximax. Let's see, for example, Maximax. I have to find. Okay, let me give you a simple and quick understanding of all these three based on the expected value which we have prepared, right? So that it will be very much easy for you to understand. Let's move on to this thing, and I'm going back. Okay. See that this is my payoff table, right? This is my payoff table. Now I can explain you with this particular thing. I have already computed the expected value, so there is no doubt on the EV. So I have covered EV over here. But Maximax, what is Maximax? See that if I am the risk seeker, I will be going towards the very best outcome. Now see that how will you identify the best? Sorry. If the production level is 3000, the best is 70,000. If the production level is 3500, the best is 81,000. If the production is 4,000, so these are the best outcomes. At 3000, the best is 70,000. At 4,000, the best is 81,000. At 4,000, 3,500, the best is 81,000. And at 4,000, the best is 85,000. So if I'm risk seeker, I will be going towards this option. That is best out of the best, right? This is called the Maximax. Now, Maximin. Maximin. What is Maximin now? Maximin is identifying the least outcome first. What is the least outcome? If I will be selecting 3000, this could be the least. 3500, this could be the least. 4000, this could be the least. And among all these three least outcomes, the best is 7,000, 70,000. So if I am having a risk averse attitude, I will be following this thing. That is the defensive approach. First identify the least outcome and then selecting the best from the least, right? So this is the Maximax and Maximin approach. I have explained it over here. So Maximax and Maximin and expected values we all know. So since I have explained you, but the question is something else here. We have to relate it with a particular this case study. So this is my part C. Now we have to study this thing. The managing director is very risk averse and is concerned that probabilities noted above may not be accurate. Remember that these two attitudes do not consider the probabilities. They do believe with their emotions, that is optimist emotions and pessimist emotions. And he or she runs with the probabilities. Now that's a very simple point. Okay, the managing director is risk averse and is concerned that probabilities may not be accurate. She has been in discussion with a local market research company who has offered to provide a fee of 100% accurate. Okay, we have concluded the value of perfect information. So she is risk averse. Now, briefly discuss for 4 marks. When it comes to the word discuss, so that simple means you have to cover 360-degree aspect and you need to discuss this and that. So first of all, you should first discuss about the expected values. So briefly discuss whether it is appropriate for the managing director to use expected values. So you first now see that the question is having a connection between expected values. Please observe and listen to me very carefully. The question is having a connection between risk averse and expected values, managing director. So there is a connection between managing director and risk averse. So shall I guide you that first or second you have to write about both of these, that is about the managing director and about the expected values first. So see that what is the expected value. Expected value is basically the probabilities and it is applied on that scenario which are frequently repeated. Let's say I am on the particular new special one of project, so I cannot assign the expected value. Why? Because I knew on this project expected value is being applied on that particular assignment which is regularly in my practice. So what is expected value? So first you need to explain either managing director or the expected value first. So I am explaining expected values, EVs, are the weighted average of all the possible outcomes considering the probabilities on the outcomes, right? And is being used for the regular work, right? For the regular work, and it is just the for the regular work which is repeated over the time, and this is just the average expected figures. Okay, but the point to be noted is that in order to execute the expected value decision making criteria, the work should be repeated and the attitude of the manager should be risk neutral. But here it was written that it has recently developed a new product, but the product is new, so how can we apply this thing, right? And EVs are or jo and that EVs are helpful for the managers having risk neutral attitude, who is neither risk seeker nor risk averse, right? So I have written it down. But the managing director, she is risk averse. So definitely you have to choose one alternative decision. And for the risk averse, she would be applying maximum decision making criteria. So the managing director is having the attitude of risk averse, that is considering a risk averse, who gets afraid from the risk, who gets afraid from the risk and considers the least outcomes and then select the best among them, selecting the best among them. And that is the technique called maximing, the defensive approach towards decision making. And the product is newly established, newly launched, and so EV is not appropriate in this situation of the product and risk attitude of the managing director, right? This is a very simple point. So the personality, the risk seeking, the attitude towards the risk is not compatible with the expected values. So that is why I have written that in what circumstances expected values are useful and who should use it. And since she is having the risk averse attitude and the product is new, so EV is not suitable, is not compatible. she should use maximum, and I have also explained. So that is the beauty of the discussion. So for 4 marks we have written enough, and it's a very good and well drafted calculation and the discussion based answer. Okay, so that is the end of this answer, and congratulations, we have gained 20 marks in full. So see you in the next lecture. Have a good day, take care, bye bye.